Hey kids, nice to see you. So today we continue our topic about plants and the superpower of plants. And after talk about the seed dispersal to see the water, sunlight, and plant growth, the need of a plant. We will see why do trees grow so tall, especially in Thailand. The tree is very big. So we'll see together why. So let's start for this video lesson.
In the summer of 2006, a group of scientists were out on a hike in California and found something really surprising. They came across this tree that was absolutely enormous, way bigger than anything else they'd ever seen. And when they looked up, they were shocked. This tree soared into the sky, way higher than the others around it. It rose 380 feet into the sky. This is as tall as a 38-floor building. It turns out to be the tallest living thing in the world. This tree, a California redwood, even was given its own name, Hyperion, after one of the Greek gods. Trees are by far the tallest living things on Earth. Adult human beings are on average about 5 or 6 feet tall. The tallest animals today are giraffes, and they're only about 20 feet tall. And even the tallest dinosaur, the Brachiosaurus, was only about 56 feet tall. The Hyperion redwood tree was about 7 of these dinosaurs stacked on top of each other. Most trees are not as tall as Hyperion, but they're still taller than the tallest animals. Why do trees grow so tall? Where are they going? Let me show you our first clue. I'm going to show you something scientists discovered while studying how plants grow. We planted 2 seeds. The seed on the left, we're going to keep in the light, and the seed on the right, we're going to keep in a dark box. We'll give them both water. After 4 days, we opened up the box covering the dark seed, and we put them back together again to compare. And we see that both seeds have sprouted. Now that shouldn't surprise you because all a seed needs in order to sprout roots is some water. We learned that in the last mystery. But what will happen if we wait longer, say 2 weeks? What do you think will happen to the one in the dark compared to the one in the sunlight?
So after 2 weeks, what do you think will happen to the plant in the dark compared to the plant in the light? So what do you think? Does the plant in the dark will grow faster than the plant in the light? It should be strange, weird, but why not? Does the two plants will grow at the same speed maybe? Or maybe the plant with the light will grow faster? So for know that we will see the next video.
All plants need sunlight to survive. So obviously,
In Japanese now. So we cannot have subtitles.
when we open the box with the one in the dark, it's going to have gotten nowhere, all shriveled up and totally dead. Wait, what? The one in the dark grew taller than the one in the light. Was this a
Wow.
fluke? Some kind of accident? Just to make sure, we repeated the experiment and the same thing happened. The one in the dark grew taller. Here you see it on the left. The one in the light is a little bit shorter. Why would the plant in the dark have grown taller than the one in the light?
What do you think, kids? So we have the evidence that the plant in the dark grow faster. Think about that. Why? Why a plant can grow faster? Maybe the plants want to grow faster because the plants think if she grows more, she's taller, she can take the sun, because you know in the forest there is a big competition between animals and plants, no, between plants, forget the sun. So you see trees will become bigger and bigger, taller and taller because they won't have sun. Maybe it's the same process with these two small plants. Japanese subtitles.
Now, just in case you thought, well, maybe plants don't need light at all, I'll show you what happened to the plant in our experiment after just a few more days. The plant in the dark is now dead. It's shriveled up. So yes, plants do need sunlight to survive. Still, it's surprising that the plant in the dark grew taller than the one in the light. Why is that? Maybe if when we did this experiment we had just added a little bit of light for the plant in the dark, something will happen that will give us a clue. So let's repeat the experiment. Okay, this time, for the seed that's going to be in the dark, let's cut a small hole in the box so that just a little bit of light gets in. Then let's check on it 2 weeks later. Ready? Here we are 2 weeks later. Look at what happened. Do you see this? The plant seemed to be growing towards the light. It's grown upwards and then through the hole that we cut towards where the light was. So it seems like the plant can detect where light is and find it. This was all a big clue to what our plant in the dark was doing. The plant in the dark got taller because it was searching for light. Growing taller was the plant's last fight to survive. Just like a starving animal might use the last of its strength to reach out for food, this plant is reaching for sunlight. If it doesn't find the light soon, it will die, just like the one in our earlier experiment died after a few more days in the dark. Now there's actually one more really interesting thing to notice here. The plant kept in the dark never really got green and grew any leaves. Its leaves were at best just these little shriveled up things. But the one in the sunlight, instead of growing taller, it turned green and grew a couple of nice leaves. Here are some seeds again, the ones on the left grown in the dark, and the ones on the right grown in the light. Now, once a plant does get light, notice what happens.
So we see the dark brown sunflower seedling, it's taller.
You see those? The ones in the light started growing leaves. As soon as a plant detects light, it grows leaves to soak up as much light as it can. Leaves are a plant's sunlight collectors. See the sunlight shining down on these two leaves? They're soaking up the light. I'm going to show you one last video, which will help you see how badly plants want sunlight. This is a sped up video of plants over the course of one day. Do you see the leaves moving? Why do you think the leaves are moving like this?
Why do you think the leaves are moving? Yes, the leaves serve the light. So you think maybe plants doesn't move, but you see how they can move during one day? They move a lot. Slower than human, but they move. Super plants.
You just saw how a plant turns its leaves so that they're facing the sun at all times while the sun is out. Leaves are a plant's sunlight collectors. Sunlight provides the warmth and energy that a plant needs to grow big. As plants get bigger, they grow more leaves to capture more sunlight. Some plants are very careful about where they grow new leaves so that their leaves don't overlap existing leaves and cast shadows on each other. This results in all sorts of beautiful patterns, such as this plant, which lives in the mountains of South Africa. Notice how every single leaf is capturing sun. Now that's a good solution for a single plant to get the most sunlight. But what about a bunch of trees all growing near each other? As they grow, they might start to shade each other.
So, kid, how can a tree get more sunlight when a lot of other trees are starting to get in its way? Maybe it can grow more, grow faster, be taller. So maybe for that we have very, very big tree.
In a forest, the trees are all growing as tall as they can. The taller a tree grows, the more sunlight it can get, and the less chance that another tree will cover it in shadow. That's why trees grow so tall and put most of their leaves up at the top. They want the sunlight. Next time you're in a forest, notice how few patches of sunlight there are peeking through the tops of the trees. It's actually really dark on the floor of a dense forest. We call the top part of the forest the canopy. Think of it as the roof of the forest. Up above you in the canopy, each tree has grown branches and put leaves wherever there's a spot of sunlight. That's why it's so dark. The trees have worked hard to grab almost every bit of sunlight, creating one big zone of darkness on the forest floor. So, in summary, plants need sunlight to survive. They'll search for it after sprouting, and when they find it, they grow leaves to collect the sunlight. They arrange and even move their leaves to collect as much sunlight as possible. And then they'll use whatever chances they get to hog all the light they can from their neighbors, like trees, which grow as tall as they can.
So now if someone asks you why do trees grow so tall, how would you explain it to them? You could say, okay, in the forest there is so many competition between trees for get light. So the tree don't have other choice that grow taller and taller for get the sun. Because like that explained in the video, on the floor in the forest it's very dark. So what is that?
It's important to understand that plants need light. But don't forget that plants also reach underground with their roots, into a world of darkness where you can't see what they're up to. Here at Mystery Science Labs, we made a root viewer that lets you see into this secret root world. So, what's been happening over the last week in that secret world? This is the root viewer that we made. It was 5 seeds placed on a wet paper towel, with the viewer placed on end, just like you see here. Let's get a closer look. Here's what one of the seeds looked like on day 1, the day we made our root viewer. Okay, and now here's day 2. The root had started to grow. By day 3, the root had grown even longer. And notice you can also see lots of those fuzzy threads. Do you remember what they're called? Root hairs. They're the part of the root that actually soaks up the mineral-rich water from the dirt. Now, check this out. Let's back up again to day 2. I want to show you something. So this is a close-up of the seed on day 2. Do you notice anything surprising? When you look closely, you can see that this seed had been pointing upward. See how the root started to come out of the top? But then the root curved around and grew downward, where it needs to be if it's going to find water. Isn't that weird? It's as if the root knew which way was down. We wondered, what would the root do if we now turned it so that it was no longer growing downwards? Can a root really sense which way is downwards? So in order to figure this out, we took the root viewer, which all this time had been pointed in this direction, and we turned it on its side, so that now the root viewer is pointing this direction. Now each root, which had been growing downwards, is pointing sideways. If the roots really can sense which way is down, what do you think will happen now? Let's wait one day and see. You ready? Day 4. Whoa, you see that? The roots figured out which way was down again. They started growing downward. So plant roots really can sense which way is down. And you can change the direction they're growing by turning them as they grow.
It's funny.
In today's activity, you're going to make one of these, a grass head. You'll use what you learned about plants to make your grass head's hair grow in the direction you want it to grow. Like, do you want the grass hair to grow straight up like this? Or do you want it to grow pointing swept back like this? You'll get to choose. But first you need to make a grass head and give it about a week or two to grow. So I'll walk you through the process now, step by step.
Okay, we cannot do that. Maybe next time if I see you in class online in February. So maybe.
Watch this whole step before you touch anything. Then fill in the top, add water, and put them in a sunny window. Put in the head. Make sure they stay wet throughout the week. Like this. It will take 1 to 2 weeks for the grass to grow. Good luck. Now you may have to adjust.
So we see grass growing day by day. So we can see the roots begin to appear. Yes, roots very quickly. There are 5 already, and the roots grow very quickly. So the soil is transformed by the fruits and the grass. And grass is a plant who don't make flower. At 9 already a lot of grass, and the soil is full of roots. He is happy with his grass now. Oh, it's for first grade, but it's okay. We will understand. So he used a plant light. It's not natural light. It's not the sun, but you can use a plant light. Not all the light, but some light can be absorbed by plants. So we can see plant dancing. Wow. So we see well in this video that plant is attracted by sun. Put the sun in the light on the side, and the plant will go on this side. And the plant can bend, no problem. A plant is very flexible. A young plant is very flexible like that. It's funny. Okay. And last video is a video walk. Okay. Okay, we have snow. It's a winter. Very windy. Yes, thunder. Sun coming. Oh, so now there is no leaf. Okay, it's autumn. Okay, we start from winter. Now it's autumn. Before will be summer. Yeah. that is the beginning of autumn. I will finally will see the leaves go back on the tree. Aha, yeah, yeah, yeah. The green leaf. Green. So that is summer. And we will have spring and summer. Okay, first year. Thank you, Samuel Ho. Thank you, kids, for watching this video. Have a good evening or a good day and enjoy. Take care of yourself, take care of your family, and see you next time. Bye bye.